The broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody.
Good afternoon, everyone.
Go ahead, Mike.
Good afternoon, everyone. Thanks for joining us. My name is Mike Short. I'm with Alliance Corporation, Director of Wireless in-Building and DAS. I'm going to present a presentation to you from CommScope, coverage and capacity from the inside out. We'll have Alec and Bashir taking it, and Bashir will be doing most of the talking this afternoon. To start with, just going to do a brief overview of Alliance, just so you're aware of the company if you're not already aware. We're a leading distributor of wireless infrastructure products. We have an extensive inventory, a lot of experts on staff, tech support and training, warehouses throughout the U.S., Canada, and CALA. We are focused on superior supply chain solutions, and we are only focused on wireless. Some of our customers are carriers, contractors, and integrators, as well as OEMs, and we serve everybody from Argentina to Alaska and everywhere in between. Some of the solutions that we take care of, obviously the infrastructure side of things, microwave backhaul, fiber, indoor and outdoor DAS are a focus of our product line, as well as supply chain solutions, which is often left out in discussions like this. If you can't get the product to site on time and installed on time, it doesn't do you much good. Our in-building solutions, from the smallest space to the largest spaces, we have product that'll fit your requirements. We also provide a complete solution of the passive side of products, whether it's antennas, splitters, combiners, as well as cables, both fiber, coax, and cat cables where required, as well as PIM test gear to make sure that the system is of low noise and high quality. I just want to briefly touch on our next webinar is going to be on Wednesday, December 10th. It's going to be Power Solutions for DAS Deployments, and that's going to be from another partner of ours, Alpha Technologies. At this point, though, I'm going to pass it over to Alec and Bashir, and thanks, guys, for doing this for Alliance.
Thanks, Mike. It's Alec York speaking, everyone. I'm responsible for DCCS solutions for CommScope. DCCS is CommScope's DAS line, and it stands for Distributed Coverage and Capacity. Bashir will be doing the body of the presentation. I think you should be very interested in the presentation, especially when he gets into areas that define coverage and capacity, because the capacity is one of the big drivers in DAS. This is a fairly high-level presentation, so if anyone has any specific projects they need information on or any specific detailed technical information that you don't see in this presentation, feel free to reach out to the Alliance folks, and they'll be able to push that over to us, and we'll make sure that you get the proper information. Like I say, if there are any specific projects that are looming on the horizon and you want some consultation on, we can certainly support with that either via CommScope or via some of our in-building wireless engineering partners that Alliance works with. So with that in mind, I'll hand it over to Bashir. Bashir is part of CommScope's business development team, and he's an ex-Verizon engineer with a specific focus on in-building system design. So vast wealth of knowledge and experience. We've done a lot of consulting with Bashir for existing clients in Canada, utilizing the experience that he's had as a Verizon person, and the fact that the States is quite far ahead of us in terms of DAS deployments. So Bashir has helped with things like sector isolation, sector overlap, solving problems like that, and based on experience he's had in real life, stadium, airport, large venue type deployments. Bashir, I'm going to hand it over to you now.
Thank you, Alec. Good afternoon. I'd like to present to you today an overview about the DAS, the distributed antenna systems, and the different components on a high level and the challenges. We start with the cellular challenges, obviously the outdoor network. It used to be over 2 decades ago when the technology was evolving from analog to digital, coverage was king, and coverage used to be the main driver for enhancement, let's just call it, both on the outdoor and on the indoor. Signals don't penetrate very easily, so it needed assistance, let's just call it, and that was the answer for that. Another challenge was the interference. And interference it could be inter or intra. It could be a self-initiated interference to a network, or it could be an interference from an unlicensed frequency or interferer out there. In this situation, it was intra-interference for the serving network in dense environment. In dense environment where you have tall buildings and multiple serving sectors accessing or getting to that building. And the last challenge, which is the most notable, and we still dealing with it today, especially today, is the capacity. The radio networks, the macro networks for the major carriers throughout North America have been having serious challenges on the capacity, especially with LTE. And the driver for that today has evolved from the coverage to that capacity. Okay. On the challenges of the, on the coverage side, you're used to the typical cell tower sitting next door to a building, a corporate office, or within a mile or two from a high-rise. And, it gets to the building, it gets to the window level, and then it doesn't go further. And that used to be the basic, trigger for DAS. Okay? And there's a lot of reasons for that. Obviously, it's because of the material and the components are put through these buildings. If you have concrete versus concrete with reinforced steel, that's a different dB or decibel degradation versus drywall or other material. So that was one challenge, obviously, one concern. The other challenges, you had the makeup of the building itself. You have underground levels, parking lots, or additional, regular levels in a hospital or a hotel where signal doesn't get to. The distances from the cell sites, you could be 2 miles away from a cell site and you have a heavy brick building that barely getting that signal to it from outside, let alone to penetrate inside. And lately, with the introduction of the 4G networks, we had a higher signal-to-noise ratio requirement. And the signal-to-noise ratio is pretty much a gauge of how good is your signal towards your noise of the noise of the network. And this metric has become really strict and stringent with the introduction of large and wide channel 4G channels for the LTE technology. On the material side, and this is this slide, says it all. You had the typical glass, call it just regular glass on a high rise that would absorb few dBs worth of a radio signal. And during the last few years, we have seen a surge of LowE Glass, where it's good for it's really energy saving for the different venues, but it has introduced another 10 or 15 decibels of signal attenuation. So to give you in simple terms, you could have 2 or 3 bars on your phone walking into that building with that LowE Glass. As soon as you go through the door, your phone will go to 1 or 0 bars. This is how much signal absorption this this type of material has, and as you can see, its effect on mobile service. But all these things are taken into consideration as part of the driver to why we would need a distributed antenna system in a venue. As I mentioned earlier, it's just the whole emergence of, the DAS in the past 2 decades was coupled also by the emergence of more advanced platforms on the mobile side, on the mobile network. And as we enjoy the higher speeds and higher throughput on our new handsets like iPhone 5 or 6 or the Samsung Galaxy S3 and S4, and it's wonderful, we also incurring a lot of load on the serving networks, not only indoors but outdoors, and that's where the problem is starting. The capacity needs is becoming exponentially more demanding as we go from 2G to 3G to 4G, as you can see on that slide. And this slide's a little bit older. It shows only the first quarter of 2013. If I was to continue that plot here, it will even go further up, more aggressive as far as the megabyte usage. And if you notice in the orange bars where the voice is, the voice didn't change much at all. It has almost a flat line to it. And that's to show you that voice services did not change as far as usage. You still use your phone with a certain amount of minutes of use every day, but the amount of interaction that you have with your mobile now is exponentially more or longer when it comes to apps and data usage. And the reason for that? Well, everybody loves the speed on the LTE. It's really more simple and more straightforward when you click a button and you download a piece of information or a website or link or a file in a matter of seconds, not minutes. And this has taken the user to download almost 3 times more, okay, what they used to download on the 3G, on the very same network that was 3G a few years ago. And that would justify the exponential growth that you saw in the previous slide a minute ago. Another factor is 80% of the mobile data that's being downloaded, it's being initiated indoors when it makes sense. If you're sitting by your desk, you're checking your social media, your email, etc., versus you on the highway driving. You're more prone to do all your data applications when you are in an idle, call it, position rather than in a dynamic. So if you're mobile on the road, you use your phone and mobile, but maybe more for like voice and conferencing, versus you're within an environment, within a building, you tend to use your phone more on the app side, on the data side. And this has triggered an 80% of all data sessions are being initiated to be indoors, which is a very serious number. And coupled with the fact that today, most of the enterprises, especially the large and medium enterprises, 90% of them actually, they are allowing to their employees to bring their own devices to the workplace. And the projected numbers that it shows that up to 1 billion handsets will be present in the enterprise world by 2018, which is an enormous number if you think about it. And the networks that are out there right now must support this smartphone handset penetration. And that's where you start thinking of DAS. And how would you create the under, or that layer under a layer, I call it, that indoor under the outdoor macro layer, to provide another layer of networking capacity. And, you know, a sample of, in North America, the larger carriers who handle most of the users, really, from Rogers to Bell Mobility and Telus, to the Verizons and AT&T down in the U.S. market, and T-Mobile and Sprint, they are starting to think to tackle their networks from inside first rather than outside. And I will give you an example. If you have a hotbed of maybe a convention center area and a surrounding area of it, let's say they might elect to do an outdoor DAS, a series of nodes with several base station sectors serving that medium to provide as much capacity as possible for the potential user concentration in the area. And this is the inside to outside thinking. So we start inside with the convention center, then we go outside and we look at the network around it. And we tailor the macro cell site, the big power site around it, to perform and to hand off in a reliable way with that DAS around that convention center. So the way of designing networks today has changed dramatically due to the fact of the capacity needs and the 4G penetration on the user side that we've experienced in the past 4 or 5 years. This is on the commercial side. We do have a public safety side. You know, we have a first responders community that have their own challenges, especially with the latest rebanding. I know in the U.S. market, let's say, we had some rebanding that happened from 700 to 800 or to 900. So when you relocate to a higher frequency, you don't propagate as well. So when you have ubiquitous coverage in a certain area, suddenly you have a coverage hole of, let's say, a quarter mile that happens to have, you know, a building or two or a park or two. And that's where DAS will become critical in these areas to shore up coverage. And in the public safety side, it's coverage, not capacity, because it's a closed, it's a closed network to the first responders alone. So you would see DAS also on the public safety side as being critical to shore up some of these challenges. And not to mention, a lot of local jurisdictions now are mandating to have a certain coverage for public safety and first responders for new buildings that they're issuing, you know, permits and zoning approvals for. So DAS is also becoming very critical on the public safety side. As far as building blocks, you're seeing a, let's just call it the block diagram in front of you here, where you have a public safety signal coming from a nearby cell site. You have a cellular, commercial frequency signal coming from a macro cell site nearby. They're going into a donor antenna on a roof of the venue or the building that you're trying to cover. And it's repeating that signal via that donor antenna and a coaxial line that will connect directly down to a bidirectional amplifier, or what's known as repeater or over-the-air repeater. And that signal coming from an over-the-air, as far as, coming from another cell site, it's experiencing loss, right? So when it comes down through the antenna, donor antenna, and the cable, it gets to the repeater, and the repeater is going to apply some amplification to it, which we call gain, and outputs that signal out via another line of coax, okay, into, in this situation, into a fiber-based active head end, okay? And the optical head end unit is nothing but a piece of equipment with multiple cards to it that will take the RF signal and it will convert it into a fiber, into an optical light, and it will send it to an optical remote unit. Then that optical remote unit could be 1, 2, 3, 10, 20 of them, depend on the size of the venue. And each optical remote unit will be connected to a series of coaxial cable and splitters, etc., and ending in a serving antennas. And that would be one way to do the system. Another way to do the system, on the lower left side, lower left corner of the slide, you see a base station that, let's say, a carrier like Rogers or Telus or Bell would elect to install next to the optical head end unit. And then they will feed the base station output into the interface card. And then from there, you will do the same process where you convert it into an optical light, up to an optical remote unit, down to a coaxial cable splitter antenna network. So what's passive and what's active? What you saw on the previous slide, there was a bunch of components hooked together, and some are active, some are passive. A coaxial cable is known or classified as passive, okay? It will distribute the RF signal. There's so much you could do with a passive components, which means an over-the-air repeater and a coax cable and an antenna, versus an active, which is the optical head end unit, optical remote unit, fiber connecting both, and onto the coax and antenna, okay? So the passive applications usually are meant for smaller venues, typically under 100,000 square feet. And anything over that, you would want to consider an active based system where you have, you know, an optical master unit and remote unit and branch out throughout the venue. The reason also, the advantage with the active, and the biggest advantage that is, it's scalable. It could tailor to a single operator or a multi-operator. It could be a single sector, serving sector. It could be several sectors from a base station for capacity needs. And it could also handle more growth and expansion. You could add more sub-racks to that system and add more remote units to cover maybe future expansion on that venue. So in the passive DAS, you have Telescope. Obviously, we have a multitude of products that goes from passive to active. And in this situation, you're seeing Node A, which is our over-the-air repeater that comes into two power options, I call it. You have the 5 watts RF modules, and then they have watt. And the concept of this repeater, which is standard actually for the industry, an over-the-air repeater, regardless of who it is that's making it, it needs to have the basic components, which is the ability to take a donor signal via donor antenna, via coax, the ability to amplify that signal and filter it properly, and the ability to take that signal into an antenna output port and send it through a network of splitters, coax, and serving antennas inside. With that particular example, you have a multi-band option here. where you're seeing a 700 on public safety, an 800 on LMR, and 900, and then 1900 on commercial. Someone decided to put a cellular / PCS commercial card in there to service cell phones as well. So it gives you that flexibility to do whichever frequencies, which is that what a proper repeater would need to do. The limitation is how much square footage this repeater could be able to handle, which is up to 100,000 square feet. On the active side, you still have some passive components. And those passive components, you have the cable, you have the donor antenna, you have, by cable is riser, let's say our LVF4 half-inch riser rated cable. Then you have our indoor fire retardant half-inch heliax cable to go through serving antennas and splitters, and then you have the repeater. Okay, so these are like the passive components that you could identify in a DAS in a building. Then you have active components, and this will be similar to our ION-B master and remote system. And those remotes could be on each floor or could be on every other floor. They're connected via single mode fiber into the master unit, the optical master unit that you saw in the slides previously. And both will mesh together to form a functioning DAS. The signal will come through the CellMax donor antenna. It will go down through the heliax cable. It will get to the Node A repeater. It gets amplified to a proper power. Then it's sent through the ION-B master unit. Then via fiber, it goes to the ION-B remote units. And from the ION-B remote units, it goes through the other set of heliax, indoor rated cable, and antennas. This slide is just a quick slide to show you what CommScope has that will address the DAS. We have, like I mentioned, the multi-band over-the-air repeater solution in Node A. We have also the ION-B, which is fiber-fed active component that's capable of anything from UHF to the cellular, PCS, and AWS frequencies. And the ION-B is known as a low-power solution that we have. And our high power would be the ION-M, which is also targeting the public safety and the commercial carrier vans, okay, for commercial service. And our newest line is the ION-U, and the ION-U would be the successor of the ION-B and the ION-M. It is all incorporated in one platform rather than two platforms, and it got more efficient and more user-friendly as far as self-optimization and setup. On the passive side, as I mentioned, you have the heliax cable and splitters and combiners, and as you see, you have copper versus aluminum-based cables. Then, obviously, Alec could talk more about the enterprise side with the fiber optic cable and products that we have. And then, lastly, we have our array of antennas. Could be omni, directional for indoor or outdoor, or could be panel antennas for indoor or outdoor as well. On the passive components, here's a closer snapshot of the connectors that will fit our cables. In this situation, you're seeing, the corrugated plenum versus a smooth wall. On the splitter side, we have our new LowPIM line as well that we just introduced this past summer. for anything from splitters to hybrid couplers to, directional couplers. And then you have the new line of antennas as well that has more stringent specs on the PIM, on the passive intermod, spec. A quick close-up on the Ion B. The Ion B, you're looking at the master unit to the far right, and you're looking at a 4-band, which is 4 commercial frequencies that would support the major carriers in North America. Then you have the 7-band, which is the first one in line here. This has all the major frequencies for commercial, for carrier applications, as well as public safety bands as well. And they're all housed into one box. And it requires just an uplink versus downlink fiber connection that will go into the optical card, and your signal is entered through a point of interface card from either a base station or over-the-air repeater into the master unit, and then you have a management card as well to monitor the system. And the point of interface card will be sending its signal via a series of splitters, okay, before it gets to the optical receiver and before it goes out to the fiber. That concept, even though this is our CommScope's architecture, but concept-wise, this is that concept. This is the basic concept of taking a signal and distributing it. You bring the radio frequency signal from outside, you condition it at the master unit, you split it into the fiber cards, and you take that signal via optical light into the remote units on wherever your system design tells you to go with. It could be multiple floors, you have multiple remote units on each floor, or one remote unit feeding multiple floors. On the ownership side, and I know in the United States they have a little bit of different model maybe from the Canadian market, but on a high level, the landlord, the preferred way to do a venue, to put a DAS in a venue, is for the landlord to fund it and have control over it. But sometimes due to the size and the scale of the venue, that might not be feasible. So carriers or third parties like power management companies, let's say, would elect to come into that venue and offer to fund it and own the system and manage it for the landlord. And that will put it into the multi-carrier or neutral host category. So you have the best option on the enterprise side, at least, is to be building owned or landlord owned. Then you have the carrier, the cellular carrier owned. Carriers might have a hotbed of users in a building. It's just putting a lot of pressure on their outdoor network. So they come up with the funding, and they will tackle that particular building by putting a DAS in there with a dedicated base station and take that building out of the capacity problem from the outdoor network. And then you have the third party. Third party, could be tower management companies or someone of that sort, where they would work with carriers to come up with a proper lease terms and then fund this particular DAS opportunity on a venue and build it, commission it, and invite the carrier to connect to it for a monthly fee. Okay, they will be the sole responsible for something like that. In the United States, you could see racetracks, shopping malls fitting that particular model. On the deployment process, there's several steps to start from scratch all the way to the end, so to speak, in a DAS design. Everything starts with a survey, honestly. You know, you have your floor plans, your equipment room, equipment location, IDF closets. You have to survey all that. And then from there, you get to a preliminary design. Your engineers, you know, derive a link budget and then an initial antenna design layout, okay, with a preliminary BOM. The preliminary design will get solidified after you run benchmark testing, or what we call it, you go collect the signal out there and make sure there's no interference to make sure that sections of the venue is accessible for DAS deployment. Once you do that, you take the benchmark data and then you do a detailed design now. And that design obviously is accurate to a point where the installer could take it and start validating the cable routes, okay? Now, some of the cable routes for equipment locations might need to change due to access issues or whatnot. That's when the designer would take the input of the installer's walkthrough notes and incorporate them into that design for a final draft. And then that final draft will go before the carrier for approval, and once the carrier approves it, they can elect to fund a base station to it or just a repeater to bring the signal from outside and power the DAS and that sort. And at that point, equipment could be procured and installation is underway, okay? So the last step is commissioning, and this is the most critical part. Whichever equipment you would be using, you have to be certified, obviously, with it. So you would have the tools to commission it properly. And I know us at CommScope, we have an extensive training class to just certify technicians and partners and integrators on how to properly commission our equipment. And we'll guide them through the commissioning process as well. But that's the critical part. You could have a well-designed, properly installed system, but poorly commissioned, and you're going to have a poorly performing DAS. Once it's commissioned properly, the results are relayed to the carriers for final approval, and once the RF signal is connected to the main system from base station and measured properly, it's signed off, and then the system is accepted. This slide shows a typical, call it scenario. I mean, it's just for, you know, it's just for the purpose of showing an example, but every DAS is different than the other. In this situation, the coverage is asking the designer for a negative 80 dBm coverage reliability, which means you're going to have 3 bars roughly on your phone connecting from one node to another. You never need to go under 3 bars worth of strength. And the designer here elected to do on the antennas, which is 360-degree antenna beam width at 100 feet or 30-meter grids. So every 100 feet, you have an antenna. And the perimeter antennas are within 20 feet from the walls. On the stairwells, you know, on the stairwells, you position antennas every few floors as well to provide coverage. And then onto the installation, the cables would have to run directly to the telco room, which is where the base stations might be and the head-end equipment might be. And then connectorizing the cables, sweeping, and testing for integrity for return loss and then overall, like insertion loss. But nowadays also, most of the integrators, if not all of them, are required to show proper pin levels on the systems due to the 4G, requirements. And pin is the most important metric today, along obviously with return loss. So once that's done, obviously you connect the antennas to the cabling, and then you do a proper closeout documentation. So what do we need to do when we're planning, obviously? Planning a DAS, you can't come in the last minute, obviously, and start planning for a DAS and not knowing the intricacies of a certain building. You have old buildings that you might not even have proper risers in them. You would want to know. You would want to know before you invest money and effort. So planning ahead is key. And the best case scenario is when a building is being constructed, especially, is never too early to plan for a DAS. You can have a say where the base station room need to be, where your IDF closets need to be, cable router, cable trays, etc. If you plan ahead, you end up saving a lot of money because you don't have to do the extra coring, the extra rerouting of cables due to difficulty on the building. Another way for good planning is future-proofing. And what we call future-proofing, technologies are always evolving. But if we plan ahead for additional growth, let's say, then you might be saving your time and money on recreating additional space, rack, for your rack space in the head-end room, or additional remote unit locations, etc. And especially when you start adding vans, right? So you might not need public safety today on that building. You might need only, the main commercial carriers on it. But it's not a bad idea to plan the equipment to hold the public safety, because at some point if first responders come in, it's just more like a plug and play rather than just rerouting cables all over the place again and costing another large sum of money to have another DAS in that building. Scalable. You have certain venues that need to increase in size. A hospital that got done with 3 sections and there's a 4th section coming up. It's good to know that there's that section, get more information on it so you could plan ahead. Plan ahead for additional base station sectors in there and additional head-end requirements and remote unit and antennas. And also, whichever component we use or you use as a designer and integrator, it is so key to check with the carriers who own the licensed frequencies that this solution that you're proposing with the brand and the model number is approved by these carriers. My background is in carriers. Okay, I come from a carrier. And during my time, I've seen multiple letters being sent to end users asking them to decommission whatever they put up there because they were retransmitting that carrier's license in an unapproved piece of equipment. It could have been a repeater or a fiber repeater or a fiber remote unit. If it's not approved by the carrier, at least in the United States, for FCC rules, they will make the end user dismantle it. And all that money and effort is gone to waste. So please check with the carriers for their approved product. And I know from a Costco standpoint, being the leading product in the industry, we are approved across major carriers. I believe here in the United States, we're all approved across all 4 major carriers. And Alec could also talk about our approval process in Canada as well. finally, you have to have that track record. So how reliable is the piece of equipment? And I could speak of CommScope. Our DAS components is reliable because the legacy Andrew was known for their amplifiers and their filters. And we've built very solid amplifiers. We were the leading amplifier company, you know, for decades. And we use that technology to build a solid remote unit systems that don't fail with heat, that don't fail with power, you know, when you have a lot of power getting emitted out of it. So the product, you will have to look at the product from a reliability standpoint as well, and not to break down. So as far as deployment recommendation, using the proper DAS integrator, that would be the best way, because you would need a qualified integrator to do that rather than do-it-yourself kind of adventure, I call it, because I've never seen those work. It requires proper qualifications, both on the design, on the integration, commissioning, and also the installation. So, and not just putting it together qualification, also the relationship with the carrier. Usually you select a DAS integrator because they could get to the proper channel onto the carriers and coordinate the system turn-up for it to be transmitting on air properly. And also having a support. So you want to have this integrator that has the support. You could pick up the phone and call in case you have a problem, and they could show up on site and mitigate the problem. So all this is just a key for you to ensure that your system is set properly, not only designed properly, but installed, commissioned, and on air properly, and not worry about it being in violation either. And that's all I have. Now I'll open it up for some discussions and questions. If anybody has any questions.
Thanks, Bashir. I do have a couple of questions that people submitted. They were throughout the presentation, so they are related to things that you talked about. The first one was, will the distribution antennas maintain E911 requirements, or would emergency services see only the address of the donor?
It will be the emergency address of the donor. However, I know based on my experience from prior, when you have a venue that's being routed over the air, obviously it's going to have the E911 information of the serving sector that's feeding that DAS over the air via donor antenna. Now, another form of DAS that could have a dedicated base station into the building itself, feeding the DAS there directly from base station. This, you could give PSAP information and give E911. You could coordinate E911 based on the address of that building. Okay? So the police department, in case there's a problem and there's a call being initiated from that building, the police department will narrow it down to that address. Okay? So, which is way better than just not having any E911 info. So.
Okay, great.
And it's just that. Okay, go ahead.
Sorry, another question. Instead of getting an RF signal from an external site, is there some equipment which can receive a fiber from the carriers to feed the VDA?
Okay, good question. Yes. So if you have this example, this question will pertain to an active system. So the optical master unit connected to a series of optical remote units in a building, okay, would need to get its signal source from somewhere. Carriers usually could put two forms of signal source within that building. Either a direct base station, okay, and they will have to bring the telco and power to it, or they could feed it from a microcell, what we call a microcell, or a small cell, which means they're just feeding it via fiber to a smaller remote unit coming and connecting from a host location, a base station that could be a mile away, okay? And that way you could have their extension, I call it, into the DAS building, and from that extension you connect via RF cable into the head-end equipment.
Okay.
Does that make sense?
Okay, I have another question. At one time, RF cables were installed connecting several antennas to a single cable run. The technology you present has a single antenna connected back to the floor electronics. Is that correct?
It was for display purposes. There's two cables that I showed, if you want to think about cables. There was a cable connected from a repeater into a donor antenna, and yes, this would be one cable to one donor antenna, okay, because it's getting one dedicated signal. But the cable that was connected from the output of the repeater, it was connected, you come out with a single cable, but you are branching out via a series of splitters into a multitude of cables and antennas, as much as your designer seemed appropriate, you know, to have for his design. You could connect with splitters all day long. I have seen up to 15 antennas from one repeater or from one remote unit.
Okay, thank you. I've got a few more questions. Just let me back up here. There's a lot. If our company has a DAS opportunity, what's the best way to get started on generating doing a proposal?
I'm sorry, I missed the last question. If a DAS company has...
If our company has a DAS opportunity, what's the best way to get started on generating a proposal?
Well, I think that's a good question for Mike to answer. Alliance has different ways that solutions can be delivered. So Mike, do you want to address that one?
Yep, sure. Reaching out to a company like Alliance, we're able to help you, guide you through the process, whether it be approvals, design, product selection, all that sort of stuff. We'd be able to help you out, so you can contact myself directly or through our website.
Okay, thanks. Let me check here now. How do you determine whether a system requires capacity or only coverage?
That's a good question. This is driven by carriers. So for a service provider, they will determine if it's capacity. There's no way for the public to know that. There is a way, actually, but you would need expensive tools to gauge that. For coverage, it's more simple. It starts with your phone. You could look at your phone, usually, and that's the first indication. And obviously, that will be giving you like one service provider worth of indication. The proper way of doing it is to conduct benchmark testing. And there are companies out there that perform benchmark testing. And what they do, they will come with their RF test equipment and data collection software, and they will walk through the building and collect the signal of each platform of each carrier in that market. And they will just output a report with the coverage of each of these carriers, so you could assess and see if you need a DAS or not. And if you do need a DAS, you have maps in front of you of the building that shows that coverage, that you could go to that carrier or to an integrator and see if they could assist helping with DAS, getting a DAS in that building.
Okay, just a couple more questions, and we're almost out of time. What is the cost per typical office tower floor of these systems?
Alec, do you? I I could answer that one based on what we have here. I don't know. It's Canada, so do you wanna chime in on that?
It varies. I mean, I've heard in between $1 and $2 per square foot. It really depends on the facility. A structure like using the high rise as an example, a structure like an office space, which is primarily will be less expensive because you'll just require less antennas. Whereas something like perhaps a hotel or condo with formed walls, you're going to need higher signal levels, therefore more antennas. The cost will rise. It really depends on.
Right.
But that number in between $1 and $2 per square foot has been.
And Alec, I could state the factors where you could come up, where you could be going from cheaper to more expensive. The factors could be as simple as the antenna design itself, an envelope wrapping antennas around the windows of every floor versus an omnidirectional antennas in the heart of each floor and propagating out. Or it could be something way more serious, like the building needed coring on each floor to create a riser route for fiber, okay? That could be a very serious cost. So, and you have the amount of fiber and copper cable that would need to be ran depending on the amount of fiber remote units that you have. And then if you have conduit, if a building requires conduit by zoning, then your costs just went up as well. So there's these factors mainly. On top of the, are you working business hours, or you have to wait till people leave for their, for home after work, so you could start your work during off hours. That could increase the cost as well.
Okay, thanks guys. One last question. Do we need to get carrier approvals for all DAS projects, even very small, low power over-the-air systems?
Yes. Even as if you were to get a mini repeater for 15,000 square feet worth of a deployment, I strongly recommend, and because I've done those approval screenings in my prior experience, I strongly recommend getting to the carrier that you're trying to retransmit their license and letting them know about it. And before even purchasing the piece of equipment, unless you're purchasing, like I keep referring to our market, to my market down in the United States, if you were purchasing CommScope's-based product, 100% sure that it's approved by all carriers. But if you selected something, a small vendor worth like a product, you would really need to check with that carrier to see if it's okay for you to use that product, if it's on their approved list, and also if it's okay to deploy that system based on that carrier's macro cell sites outside, because that carrier would still need to tell you which direction to point your donor antenna to get the appropriate signal. So you actually need information from that carrier rather than just the carrier needing information from you.
Yeah, and in addition to that, the carriers, like Bashir mentioned, they own the spectrum. You're rebroadcasting theirs. And just in the event that there are some problems or changes to the network, they need to know where those repeaters are so that they know what's happening on the network.
Absolutely.
Okay, great. Thank you, guys. That's all the questions we have. If anyone has any more questions after the fact you think of, you can just email them to me, and I'll forward them to Bashir and Alec. Okay. And I'm going to say thank you to you guys for the presentation today. You did a fantastic job. Thanks, Mike. Do you want to have a few words?
Just want to remind everybody, the next one, Wednesday, December 10th, as previously mentioned, the Power Solutions for DAS deployments. So look for that in your inbox.
And one final housekeeping note, I have recorded this webinar, so I will be sending out an email after with a link to the recording where you can watch it anytime you want, and you can actually share it with, I think it's a fantastic presentation to share with potential customers, clients, because versus a lot of other DAS presentations, I think this one speaks to, that kind of level where the end user can understand.
I'm glad. I'm glad. Thank you. Thank you for having us.
Thank you, everyone.
Happy Thanksgiving. Oh, actually, we're in Canada. Thank you.
Okay, so, yeah.
Happy Thanksgiving to Bashir.
Okay.
Thank you. Thank you.
Bye. Thank you.
Bye-bye.